Good afternoon.
Hello.
So, what are we doing? Well, we're continuing on with test 3 here. Now, what I'll do, I was going to go over mainly the roadmap problems today, and possibly another synthesis problem. Might do that. Okay. If I could ask everybody to just have their video on, please. Victoria, I don't know, maybe you've got yours blocked or something. Elise,
I forgot to
Sylvia,
open it.
yeah, Sylvia, and Elise. I can see your ceiling, but not you. There we go. Deanna, Katie, yeah. I don't know. Sometimes I don't go check. But, you know, that's the thing. I'd like everybody to be on the call, please. I mean, show your video. Sylvia, Deanna, thank you.
I just sent you a private message.
Oh, okay. All right, no worries. Thank you, Deanna. All right. All right. All right, fair enough. Okay. Let's get back to where we're going here. So what I'm going to do is, let's see, we'll do some examples of roadmap problems. I'll start with this one. So this is spring 2016. And that's what the roadmap problem looks like. Okay. So let's see how we go about it. Now, as I had talked about with these, I talked about these when we were doing test 2, you don't have to do it just one way. You can do it by going backwards. If you have an idea of what you're looking at down here, you might be, or you might know what this is, for example, then you can work your way backwards to get these other things that are going here. And for this one though, since there is a bit of a lack of information about what's down here at the end, you're probably better off just mainly plowing through from the beginning on this one. All right, so a couple of things I can tell you here is that with this reaction, the lithium aluminum hydride and the NaH plus, I'm only getting one product here. So if you were coming up with an answer where you were getting two products, I think you should be thinking twice about how you're actually doing the reaction, because it probably means that you're making some sort of error. So even though this does get two products, these two products are actually the same thing and they're labeled A. So it's two things you're getting, but it's actually the same thing. I'll show you what I mean. So the result of this reaction, I'm not going to do the mechanism or anything on this because, you know, this is not the time for doing the actual reactions. Oops. Okay. So that's from one side, and this is from the other side. So both of those are actually the same, and that's going to be A. Does anybody have any questions so far? All right, so how else might that be helpful to you? Well, if you go back to question 1, you see there's this reaction down here. So if you know what A is here in the roadmap problem, or you can sort it out by perhaps doing a little bit of reverse engineering, then maybe that helps you get the answer here in question 1 if you didn't know or couldn't remember exactly what that gave you. So I guess what I'm trying to tell you is that don't just use, don't think of each problem by itself. You need to talk about the entire test and use information you gain in other parts of a test to help you with parts you might have missed previously. And that this might be an example of that. It's probably not the best example. I'll show you better examples of this kind of thing later that are a bit more clear than that, but that's something that might be helpful. So once you've got A, then you can try and get B. And B is going to be that, so it's B. But there's one other thing about A too. I mean, actually, I didn't even realize that. But if you actually do the hydrolysis process on the thing you start with, you'll get this, and you'll get A. So A will already be the same thing. That's how it might help you with question 1, because you can actually already get A by other means. You didn't have to do it by remembering what this reaction was. So that's something to think about. Does anybody have any questions so far? Okay, so once we've got B, then we can get C, but it's going to be C plus something else. And that's going to be this alcohol here. But the product of the B and the 2 Grignard reagent equivalents there is going to be that plus the alcohol that you see here too. 1, 2, 3. Which is that one. And that alcohol is already mentioned there, so you don't worry about that. So this is what C is. Does anybody have any questions so far? I think it's probably safe to say that, I mean, when you look through all these roadmap problems, that you'll see a lot of repeating reactions that are used a lot. Grignards are pretty common. The lithium aluminum hydride, you might see that. Another one you might see is the copper lithium one, which I'll show you in another example. But there's things here that are going to be helpful as you go through this. Let me see something else here. I just want to look at the synthesis problem, see if that would be helpful. Yeah, you see, even the synthesis problem might involve the lithium aluminum hydride as well. So if you were aware of that, that might be helpful in solving the synthesis problem too. All right. So that's your A, B, your C, then the D. Well, that's going to be going to be that. Does anybody have any questions? That's D. And then the last one here is the lithium aluminum hydride, which gives apparently E plus C. You already got C from up here, so you know that that's one of the products. And then you could also then get E, which would be that. But you know, one thing I can obviously say is that if you know the reactions, it makes doing this a whole lot easier. If you don't know any of the reactions, then getting the right answers on a roadmap like this are going to be very tough. Does anybody have any questions at all about this roadmap?
Is that C at the end the same C that we found after we did the Grignard reagent?
Yeah, it's the same C. So if it's this C and this C, if it's the same letter, it's the same compound, Deanna.
Okay.
Any other questions? Okay. Let's take a look at spring 2017. Okay. So you know that lithium aluminum hydride reaction, you'll see that in a certain number of these roadmaps. You'll also see this one too, with the copper lithium here. So let me just talk a bit briefly about the copper lithium reaction. So generally, if you've got, I'll just do a general thing here. So it's the reaction of an acid chloride I don't want to go too much into the theory. I do that in the actual discussion in the video where I talk about this. But if you've got something like this, it's a copper lithium reagent, it's sort of treated like a Grignard reagent, and the active ingredient here is going to be effectively that, which is, you know, the 4-carbon chain with the negative at the end for the copper. So you treat it much like a Grignard reagent, but you ignore the second equivalent. So the product of this ends up being this, where the group here replaces the Cl. And it's just like one of those basic type mechanisms I talked about, or negative type mechanisms where the negative comes in and kicks out the leaving group. Anybody got any questions about this so far?
Dr. Musgrave,
Mm-hmm.
for the one that looks like the copper lithium thing but has an NH2 group on it, why do we put 2 on that when we're reacting?
Could you repeat that, please?
So like the same kind of like parenthesis kind of things with the NH2.
The NH2.
It was in the 57 question on the blue.
Oh, I don't know. I'm going to have to look at that.
Okay.
Courtney, I'll do that after. I'll do that after I've gone through these roadmaps. Okay.
Okay, thank you.
Does anybody have any other questions about the copper lithium reaction? Okay, so let me tell you how this is kind of helpful. If you've got this here, you've actually already got the product here. So that's kind of neat. And then in question 1, you'll notice that there's a copper lithium reaction in there. Where is it? This one. And if you didn't know what the answer was to that one, then this actual answer in the roadmap actually helps you, because you already have the answer to a copper lithium problem here. And if you could maybe work your way backwards, you could possibly figure out the answer to that question as well without even having known the copper lithium process. It didn't hurt also in this one that, well, actually didn't look like it's going to help with the synthesis there. Okay. But sometimes it might even help with the synthesis, and you just never know. You just never know. The other thing is that it helps you with B as well, because if you go back to number 1 and you see that there's this copper lithium process here, what's it reacting with? Well, it's reacting with an acid chloride. So that tells me that B is an acid chloride. So it's a C double bond O to a Cl compound, which can be helpful. And then if we work our way forward, then maybe getting B is not that difficult. So again, we get 2 products, but they're the same thing if we do hydrolysis. Let me do something a little bit more consistent. There we go. That's better. Sorry, my computer's slowing down for some reason. All right, so that's going to be A, but there's really 2 equivalents of the same thing, but it's still A. Now B is going to be that, where the OH gets replaced with the Cl. And then you can see that that would complete that, and then that might help you to get the answer to that one in question 1 if you didn't remember what this reaction actually gave. Does anybody have any questions so far? Okay, so the reaction over here gives A, which we've already got up here, and C, which is going to be the other product. So it'll be that. And then you would work on C. And you would have the possibility here of being able to work your way backwards to get E. And if you were able to get E, maybe that might help you get D, possibly, if you weren't really sure about how to make this Grignard reaction work. But the products for the Grignard would be, well, let's have a look. We'll get E first then, just so to make it a little bit easier. And you can see that E will be, well, let's have a look. It would have to be, if this is the carboxylic acid, then E would be this. So you know that, well, the way you'd know that is if you take the carboxylic acid and you add it to this, this will be the ester that you'd end up with. So if you know that's E, then getting D is going to be fairly easy, because the reaction with the Grignard reagent would give these 2 compounds. Now this one happens to be D, and E would be the one that we got up here. It's the same thing. All right, does anybody have any questions? Okay, I'm not sure how valuable this is. The part of the reason it might not be that valuable, what I'm trying to show you here, is that a lot of you aren't really familiar with the reactions yet. So I imagine looking at something like this can be pretty daunting. It's kind of looking at something and not having any idea what it is really. But what I want to do here is I just want to see what your concept of the, let's see, this one here. No, not that. Okay. So just about, so just do the poll here, and just all I'm interested in is how you are about the concept of the roadmap, not so much the reactions. Okay, I mean, look, I'm accepting of the fact that a lot of people don't know the reactions yet. Okay, I'll give you 5 more seconds. 4, 3, 2, 1. All right, so this is where we're at. All right, so with those people, you know, it's about probably about what 70% to 30%. With the people who don't understand or halfway understand, are there any questions that you could ask that would be helpful as to what's going on with these roadmaps? Anything you could ask? Okay. Jasmine, were you going to ask something?
I guess I got a little lost on D. I understood how you got the products for ABC. It's just D. I was a little D and E. It was the one where I was a little confused. I was like, how did he get that? I'm not particularly.
Well, E I got back by going backwards.
From okay, let me look.
From there, okay, let's go back to that. All right, E I got by going backwards here. Do you understand how I got E?
Yes.
Okay.
I write this down now. Sorry.
But if you know E, that's fine. Then when you do the reaction on C, let me see. I don't know if I can bring this back. I might be able. There we go. The products of C and the Grignard reagent are going to be D and E. So it'll be this one and this one here. But we already know what E is, so the other one must be D. But I'm not sure if that's your question or not. If you're asking about the actual reaction itself, that's not really relevant to my discussion here.
No, I'm good. I was
But-
just a little lost.
But I don't know. Hopefully I answered your question anyway. All right, any other questions?
I just want to clarify about D. D, so you added 2 Grignard reagents. Is that why that looks like that, D?
Mm-hmm.
Okay.
But again, Deanna, I'd have to go back and explain the entire reaction. That's not really my purpose here.
No, I got it. I just needed to clarify that part.
Okay. Yeah, that's the thing. If you focused on the reactions and you haven't done the reactions yet, this is going to look like a real mess. At the present, all I'm trying to do is just show you how you can, well, the basics of how you do the roadmap if you have the requisite knowledge. That's really what I'm trying to focus on here. And also how the roadmap can be useful in finding out things from the test that it might give clues to other things on the test. And that's the other thing I want to kind of alert you to as well. Okay, so here's this copper lithium one again. And the lithium aluminum hydride is in here as well. All right. Okay, let's take a look at this one. So this one actually has more clues than it looks like it does. First of all, when we're doing the actual first reaction with the H2O and the H+, the products are going to be, see, 1, 2, 3, 4, 5, 6, 3, 4, are going to be this and this. And initially you won't know which is A or which is B, but what we do know is that when A is treated with SOCl2, and the only reaction we've dealt with SOCl2 would have been with this one. So that would have to be A. And that would also help explain the product that we're getting over here if we know that we're adding 2 of these equivalents of the copper lithium reagent. So this business here is the bit that comes from the copper lithium. You can see the 3 carbons, and this must come from the rest of it, which makes C the acid chloride that results in that. So we can get that by working backwards. That's C. Does anybody have any questions? So if that's A, then this is B, and we already have B down here. B is going to be the product of the lithium aluminum hydride reaction. So we've already got that. All right, then we can get D, which is from the addition of the carboxylic acid to the alcohol, which is going to be this. 3, 4, 5, 6. So that's going to be D. Does anybody have any questions so far? Now remember, we've already got B, so we're really only after E. And then we've got the Grignard reagent, which is going to react with that. To form that, that's going to be E. And B we already got from up here. All right, does anybody have any questions? So again, I want you to notice that we have this copper lithium. We actually have a product of it here. And again, you know, we can go back to question 1. And there it is again, there's that copper lithium reaction there. So if you didn't know what the answer to this was, you might be able to get a clue from the roadmap. All right, does anybody have any questions?
You worked it backwards on to get C, but couldn't you could do the chloride knowing that the chloride's going to kick that off?
Oh, sure. Okay. Yeah, but you know, also the other thing, Peter, is that initially we didn't know what B was because, you know, we get A and B, but the point of it was that the only thing that could react was the acid to get the acid chloride, not the alcohol. So yeah, but you're right. But again, that presupposes that you know what B is.
So you can kind of check yourself because when you go back, you could see the 3 carbons are added there.
Right.
You know the rest of it would have been
Yes.
what you went with. Okay.
That's right. Yeah, you always get more out of these than initially when you first look at it. There's a lot of it. There's a lot of stuff that you can actually get just by taking a closer look at things. All right. Any other questions about this one? Okay. Okay. So you will notice this. The Grignard one seems to pop up a lot, doesn't it? So does the SOCl2 as well. And now we've got this Dibel one down here, which might be confusing as well. But now with the Dibel, again, you know, I told you there's no guarantee that there will be a relationship to question 1, but you never know, there might be. So you could look through here to see if there was a Dibel anywhere to help you out. I wonder if there is on this one. There is, look at that. So you got the acid chloride. You know, it's the acid chloride that reacts to form the with Dibel. And if you've got the actual product here, which you have for the roadmap, that might help you to get D. But you already knew that D was an acid chloride because SOCl2 would form an acid chloride as well. But if you were to use that pattern from question 1, you might realize that D was that without even really having to do very much else. It's not entirely necessary to have gotten D that way, but it is possible to get it that way. Now with the first one, you know, adding the Grignard here, we're getting 2 products. This alcohol, and oops, and this alcohol here. Let me see. 1, 2, 3, 4, and then this. Okay, so this is going to be A and B, but we don't know necessarily which is A or which is B yet. What I can say is that if we know that that's D, it's more likely that this here is going to be A, because A has the same number of carbons as D does. Or even if you want to look at this, you can see it's got 4 carbons. There's no way that B here could ever form anything that even looks remotely like this, given its initial structure. So it's a fair bet that this one's A and this one's B. Now, if we know that that's A, we can check ourselves here. CrO3 would give the carboxylic acid, which would give D, which we've already got. The carboxylic acid is going to be C, which again you could also get by reverse engineering D as an acid chloride and putting the OH back on. So even if you didn't know what CrO3 did, you could get it by going backwards from D to C. That could happen. The only thing we're left with is E then, and E would look like this. I'll move it over a little bit. going to be that. So that'll be E. Does anybody have any questions? Anybody have any questions? All right, let me see how you're doing with just a general concept of the roadmaps. Not the reactions. I know that a lot of you don't know the reactions yet. Just a general concept of roadmaps, please. 5, 4, 3, 2, 1. All right. So does anybody have any questions that could help here? All right. So what I thought I would do is I'd go over another synthesis problem, since that seemed to be a bit of a challenge. I'll look at spring 2019. And I'm using a key here because I told you you can use the reactions from question 1 to help you with the synthesis problem. So let's take a look. Excuse me. Where are we? Okay. Not that one. This one, okay. All right, so we're trying to go from this nitrile to this amide. I think it's initially good to maybe do a little bit of structure analysis here as well. Knowing what we're looking for, there's A, B, and C. I think it's useful initially just to sort of view that we have this moiety here and this moiety here, they're the same thing. So that can be kind of helpful. So what I would do first is I would look at the product and find a reaction that gave a product with a similar functional group. That is a C double bond O with an N. It doesn't have to have the H on it necessarily, but look for something that's giving a C double bond O with an NH as a product. This has a reactant. We don't want anything to do with that right now. Which one gives a product that looks like that? That one does. All right, so the reaction or the base reaction we're looking at is this one. So I'm going to copy down here. And the product, obviously, if you didn't know what the product was, you'd be in a bit of trouble, but let's assume you've got the product. You got that. So this is a similar functional group to the one we have. And we know how this product came together. So what we can do is we can say, well, what would have formed that? And what would have formed it would have been this carboxylic acid. And then C would have had to have been that, Amy. So if you look at the pattern, you can see that the N joins on to the C double bond O, and the H and the OH come together as water. So that's where the extra H comes into play here. But that gives us the B and C. The reason I chose B for being this and C for being this and not vice versa is that I know what the structure of the initial compound is, and it's most likely to form B as this rather than this. Does anybody have any questions? Okay, now what I want to know is how you feel about the figuring out of B and C. How do you feel about how I got B and C based on that reaction? Okay, I'll give you another 10 seconds. 9, 8, 7, 6. Okay, everybody's voted now. All right. So it looks like about 3/4 of you are there, and 1/4 of you are still struggling a bit with this. So I need to figure out what's going on here. So questions?
Could you maybe do another example?
Well, Keisha, do you have a question about this specific one?
Not in particular. You froze while you were doing it. I see it, but I didn't really get to see the part where you did B and C.
Do you see where I got B and C from, though?
Yes.
Okay, so I got it from that reaction. And just to be a little bit more clear, what I can do is I can look at the product, and you can see the different places where the reactants came into play. So there's this, and I can put that in a circle, put that in a square, and this is the circle part, this is the square part. And if I was to redo this, this would be the square part, and this would be the circle part. So what I'm saying is, if you know how this forms, then we can know how this was formed. But Keisha, I will do another example in a second, but does anybody have any other questions about how to get B and C?
My only question was where did the how do you get the 2H on C?
Okay. Do you see in the reaction, the base reaction that we're using, we actually lose a hydrogen when we form the product? Do you see that? It's NH here in the reactant, but then it loses the hydrogen in the process. Likewise, that's what's going to happen here. This has to start with 2 hydrogens to be left with 1.
Okay, I get it now. So it would have had to.
Yeah, but that's kind of subtle, though, isn't it? It's kind of subtle. All right. Any other questions?
I just want to make sure you use the hydrolysis to get from the first one to B.
Oh yeah, I haven't done that yet. I haven't done that part of it yet. I'm still working on B and C here,
Oh, okay.
Julie, but I will do that in a second. Spoiler.
Sorry, I wasn't sure.
That's okay. Any other questions? All right, let's go back and find A here. So we're looking for a nitrile going to a carboxylic acid. And there we go. Nitrile goes to carboxylic acid. So that would be the reaction there, and just copy it down. So OH minus, H2O, and
Did
H
you have to
plus.
use the OH minus?
No, not necessarily. How else might you do it?
Could you just do it with the H2O and the H plus, like in a
No.
No.
Oh, yeah, you could. You're right. Just H2O and H plus without the 1s and 2s. Yeah. That'll work. You wouldn't have to, but when I did this, when I prepared the synthesis question, I did it based on reactions that were in question 1. So you don't have to use them, but most people will anyway. But yeah, that's fair enough, Julie. H2O and H plus will work too.
Thank you.
All right, any other questions? All right. Which one is this? It's test 3, Spring 2019. Okay. All right, let's look at another one here. Yeah, the hard part is just that first part of peeling it back, and there we go. All right, so what I would do, the approach I would take, I would go back to question 1, look for something that forms a similar functional group to what you're seeing here. It has to be a product. So I'm looking through it. Oh, there it is right there. So this one forms, this one's this. Okay, so there's our base reaction, SOCl2. Okay. So what I would want you to understand is that this product could be formed by treating this compound. Well, actually, let me put it on B. With SOCl2. So what I want to know is how you feel about B and C based on that reaction. Give you 5 more seconds, or 3, 2, 1. Oh, good. Everybody understands that, and that's nice. A couple of people didn't vote, though. Any questions? All right, so then we would need to figure out how to get from here to the carboxylic acid. So I'm looking for a reaction that starts with an amide, C double bond O to an N, and ends with an OH, a carboxylic acid. No. There we go, that one does. So again, it's that hydrolysis process. And yeah, Julie, you could use the H2O and H plus on that one as well. And that would be A. All right, any questions? Keisha, does that kind of clear things up a little bit for you or not?
Yes, that helped a lot more. Thank you.
Okay. All right, so does anybody have any other questions to ask about synthesis problems? Okay. All right, Courtney, you had a question. It was in the blue book.
Yeah.
Courtney.
It was one of the reactions in the blue book.
Okay. See, I'm going to open up the floor here to any questions anybody has about anything here about test 3. But I put Courtney off earlier. So what? Let me see if I can find it. What problem was it?
But one is on number 12.
12? Yeah. Okay. Oh, okay.
Yeah. So like, why would it have 2 things attached to it when the copper lithium only has 1 when you react it? If that
Well,
makes
see, this isn't the copper lithium process. You know, it's a completely different reaction. This one. I think maybe you might be misinterpreting it. I mean, if you were to draw it, it would look like that. Maybe that would help. I don't know if that helps or not. But that's how you should be interpreting it. The
One
thing on
thing
the arrow.
I get confused because the CULI has like a 2 by it too. So I would expect it to look different.
Well, again, if it's got a 2, that's how, again how you interpret it.
So then you just break up the double bond for the oxygen and the carbon, and just replace like the same steps before, like the guidelines you gave us.
Mm-hmm.
I got it.
Yeah. But again, Courtney, only one of those reacts. So it would just, that part replaces the Cl for number 2.
I think I was getting confused because they both look the same.
I'm sorry, Courtney, I can't hear you.
Can you hear me now?
I can't hear you, Courtney. I'm sorry.
Not at all.
I can now.
Okay. I think I'm just getting confused because it has like that same parenthesis kind of setup. So
It does, but you know the reactions are very different.
Right. Okay. Perfect. I get it.
But I'm just showing you how to interpret it. That doesn't really change anything there. All right. Any other questions? Any other questions? Questions about anything to do with test 3? Well, I'm opening the floor here. If you weren't here on Thursday, I just wanted to point out something that I pointed out to everybody else who was here on Thursday, that when you look at the videos, there's so many videos here that it doesn't show them all. So you have to hit load more. And in amongst those load more ones, there's a what to expect for test 3. There's something on NMR and functional groups, which is interesting, reaction classifications, and common mechanistic patterns as well. So, you know, it's if you don't hit the load more, you won't get to see those. And some of those are pretty interesting.
Dr. Musgrave?
Yeah.
In the blue book for problems 56 and 57, do we need to know those ones?
Let's have a look. I may be able to answer that. Let's have a look. Well, I'd say that they're oddballs, but I'd say you won't see them on the test.
Thank you.
There's a little gift for you, Mariah.
I appreciate that.
But they could have been, but they're not. And see, all you had to do was ask.
Which ones aren't going to be on the test again?
56 and 57. Do you see them there?
Yes, thank you.
Yeah. They're at the end of the reaction summaries. You won't see them on the test. I pity anybody who not here or doesn't watch the video. Any questions?
I wasn't here Thursday, but did you go over NNMRs for this test? Or
Well, what I went over some functional group things, but I can go over an NMR if need be. But what I did was, there's this, do you see this video here, Peter? I went over how you can determine what functional group you have by looking at the molecular formula of what you're given, which is semi-interesting. So I'd recommend that you watch that video to get it, or you watch the Zoom session from last Thursday to get an idea of how to deal with that. But I can still, but I'm still open to going over an NMR if somebody wants me to. Does somebody want me to?
I mean, I do, but I don't know.
Okay, Peter, that's all right. See, all you have to do is ask, you know, that's the thing. Yeah, see, you're not the only one, Peter. See, you opened the floodgates, buddy. All right, let's have a look. Does anybody have a special request for an NMR? No, nobody does. All right, I'll just choose. Oh, I want to choose one that there's one I really like here. I wonder if it's this one. Might be. Can't remember. There's one it's a really good one. I wonder if this is it. It'll do. Yeah, it'll be fine. All right. So C13H18O2. And what that means is it's either an ester or a carboxylic acid, but we know it's not a carboxylic acid because there's no peaks between 10 and 12. Did I go over this one? Looks semi-familiar, but anyway, they kind of all begin to look the same after a while.
That was the thing.
I've already been through that one, haven't I? Yeah, all right. Let me try a different one. Try this one. No, that one's a bit simplistic. I don't like that so much. Let's look at this one. No, it's not my favorite either. I like to, let me do this one. Yeah, this is a good one. I like this. All right. So again, it's definitely an ester for the same reasons as I had before. C14H20O2 could be a carboxylic acid, could be an ester, but it's not a carboxylic acid because there's no peak between 10 and 12. So we are looking at an ester functionality. So I know automatically, this is before I even do anything, that the functional group that's present is going to be something that looks like that. And then I can go ahead and get started on how to deal with it. Now at 4 ppm, I've got 7 peaks for a CH. So I know there's a CH here directly connected to an oxygen. Further, I know that that CH is connected to 2 CH3s. So that's the other thing I know as well. But generally I don't do that. I always C14H20O2. And then I've got my groups. I've got my C6H5. I've got my CH, CH2, CH, CH2, CH3, CH3, and another CH3. Oh dear, I don't like that at all. Let me do that again here. That's not going to squeeze all that in. Let's do it over here. C6H5, CH, CH2, CH, CH, CH2, CH3, CH3, and CH3. So a question you might have here is, how do I know the 6H and 3 CH2s? Well, according to my guide, if it's 1 or 2 or 3 peaks, it's most likely 2 CH3s. If it's 4 peaks, it's most likely 3 CH2s. So that can be helpful there. So C6H5, CH, CH2, CH, CH2, CH3, CH3, and CH3. So that's what we've got. Now I've already, and when we do the subtraction here, we can count it. We've got 6, 7, 8, 9, 10, 11, 12, 13. There's a C left over, there's an O left over, and there's an O left over. The number of double bond equivalents here would be, see, 28, 30, be 5 double bond equivalents. That's 4 at the C6H5. So we've got 1 double bond left over. So we know we've got a C double bond O and an O. Does anybody have any questions so far? Now what I always like to start at 4 ppm, because I know that anything at 4 is directly attached to a single bonded oxygen. So that's why I went ahead and connected the O to the CH like I did here. I also know there's 2 CH3s here, and that would be the 6H. So I've actually already accounted for the 2 CH3s, the O, and the CH over here has been accounted for. All right, so the rest of it is what needs to be fixed up here. And I can look through the rest of what we have here. I've got a CH3 that's got 3 peaks. So that CH3, which has to be this one, by the way, must be next to a CH2. And which CH2 is it next to? Well, you got 2 CH2s here. It's not next to this one because that doesn't have enough peaks, but I do have one here, CH2, that's got 5 peaks, which suggests that that CH2 is adjacent to 4 hydrogens. So we've got the CH3 here connected to the CH2, that's 3 of them, and then we got that connected to a CH, which would suggest that that's this CH here. This CH has already been accounted for. This CH has 5 peaks, so it must be adjacent to 4 hydrogens as well, but it must be adjacent to, well, it must be a CH2. So that CH must be between 2 CH2s. Now I've already got the CH, one of the CH2s accounted for, and that's the one with 5 peaks. And the other one I haven't accounted for yet, but that must be connected to the aromatic ring. So the structure must be something like this, with the C double bond O here, then the O, and connected to the CH and the 2 CH3s. Yeah, I must admit that one was a bit of a challenging one, but yeah, that's how it came out. Anybody got any questions?
How did you know that it was attached to the aromatic ring and not attached to the other side?
In other words, what you're asking, Julie, is how do I know that these two groups weren't switched?
Right.
Right. The thing is, if you look at the peak structure of the aromatic ring, it suggests that it's connected to a CH and not a C double bond O. If it was connected to a C double bond O, that would be split.
Right. Okay. I always forget that.
Hmm.
Thanks.
Any other questions?
Can you write it a little neater?
Oh gosh. Okay. I'm getting schooled here. All right. All right.
Miss Grave.
All right. Let's have a look. Let's see. I'm gonna write it as a line structure. Might look. See if it's a little bit prettier. What do you think of that?
Perfect, thank you.
But I think one of the coolest things you can do is look at 4 ppm and start there and know that that's connected to an oxygen. And you can get that from the correlation chart, by the way. All right, any other questions? Any other questions? Jacinth? No.
No questions right now.
Okay. Anybody got any questions? All right. Nobody asked me. I thought I'd be pressured, but nobody asked me about putting up more old tests. So you don't want any more old tests? Do you think you have enough up there?
It would be nice.
Upload one more.
Well, nobody asked me. Last time I got bullied, pressured for tests to put more up. But no. Then after that, nobody seemed to want them. So I don't know.
Oh no.
Oh no, I shouldn't make that assumption.
Wow. We're bullying you now. So just
okay. All right.
We are bullying.
Okay. All right. Then I will. I'll add at least one more. We'll see. All right. Any other questions? Okay. All right. Well, we'll leave it there then, and I will see you all on Thursday. You all know the drill, I think, by now.
Thank you.
Yeah. Thank you. Bye-bye.
Okay. See you later.
Yeah. Did he leave? No.
Dr. Musgrave,
Yes, Jacinth.
is there a way that I can try and figure out how to upload it or download it to the Dropbox?
Well, you can just practice using the Dropbox. I think it's open.
Which one?
The test 3 Dropbox. I think it's open.
All right, I'll try. Thank you.
All right. Let me see. Hang on, Jacinth. I'm just going to check. Test 3. Yeah, it looks like it's open. All right.
Okay. All right, thank you.
Okay.
I have a question.
Yes, Jasmine.
I took your advice, and I've been working on the problems like all day from the 57 problems. And when you were doing the roadmap problems, I got when you were doing copper, lithium, and dibel, because I guess I'm just having trouble with the Grignard reactions. And that's weird because I watched the video last night before I went to bed.